So today I will ask him a bunch of questions around the mass adoption. Okay, so what I think the most two important challenges for now for the mass adoption, one is scaling, and then the other is how do we onboard the user to have a friendly wallet. So for scaling, scaling actually is we want to have we want to make the transaction more cheaper and can running fast. So what is could you brief introduction, give a brief introduction of the roll-up and the layer 2 to the audience.
Okay, here. So a rollup is basically a system that looks like feels to the user like a blockchain. You can send transactions to a rollup. Transactions get executed inside a rollup, except all of the computation and most of the data is done off-chain. The only thing that's done on-chain in a rollup is that there is a small amount of data and proving that's happening on-chain. And the goal of this is that a rollup gets the same level of security as anything that is happening on the blockchain itself. But because most of the data and all of the computation is happening off-chain, you get a much higher level of scalability. So this is a scaling solution that increases the number of transactions the Ethereum ecosystem can process, and at the same time reduces transaction fees.
So does this mean we can have a cheaper transaction and with a higher TPS?
Yes.
So in your opinion, what is your favorite layer 2 solution right now? Maybe I will change my question. Okay. 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 Another question is we always heard from other, layer 2 solutions. Someone said that the sequential right now is more centralized. So how do you see this problem?
Yeah, okay, so maybe just for introduce what a sequencer is. Basically, roll-ups, because the transactions do not go on-chain directly, they go into this other system first. And so that system itself needs some way of agreeing on what order it's accepting transactions in. And the simplest way to do this, unfortunately, is to have one server that accepts transactions and then puts those transactions together into batches that are called blocks. There are other and more decentralized ways of doing this, but they take more time to implement. They require you to have a consensus algorithm. They're more complex. And so right now, people are just, for their initial versions, going with a centralized sequencer. I mean, my opinion is that decentralizing sequencing is not the first priority. I think it's the second priority. I think the first priority should be hardening the proof systems, right? Because right now, all of the rollups that are in place, they still either don't actually rely on their proofs, or they have some kind of override mechanism, they have some kind of security council or something else. There's still some group of people that can override the proof in case the proof has a bug, right? But this also means that that group of people actually has control over the system. And so I think we need to really focus hard on, every layer 2 team needs to really do this, focus hard on getting to the point where the underlying proof technology actually is trustworthy and secure enough that you don't need to have these extra override mechanisms, or at the least you can give them much less power, right? So one example of how that might work is you might have two different proof systems, and your security council or whatever your override mechanism is would only have the power to decide if those two proof systems disagree with each other, right? So that's something that I think layer 2s really need to spend a lot of time working on. But then once that is done, then obviously the next major goal should be to avoid having relying on a centralized sequencer, and really getting to the point where the rollup can survive and can keep running even if the entity that's building the rollup, whoever the company or the organization is, completely disappears, right? And I think we're still quite some time away from that, but we're definitely starting to get closer. And like, there's decentralized sequencer designs that are like very understandable how they work in theory. I feel like in theory we basically understand the problem, but like actually implementing it is a big challenge, right? And these people, like the teams building these projects, they have a lot of experience working on either fraud proofs or zero knowledge proofs and like writing EVM in weird languages, but they don't yet have experience doing consensus algorithms. And so I expect it will take some time, but like that's okay. That's it's something that the ecosystem just needs to work on, and I think in a couple of years it'll be solved too.
Yeah, I agree. I think that decentralization is good, but since we are running some experiments on layer 2 solution, so even though it's sequencing is kind of centralized, but it doesn't mean the security is not guaranteed on the mainnet. So yeah, it should be fine. But I think that most of people, they might, misunderstand decentralization and the centralization. So yeah, I just want to clarify that this is the point. And okay, so the next question is about the Ethereum Cancun hard fork, because since we are talking about the layer 2 solution, so of course we want to making the transaction fee lower. So how do you expect the next hard fork we can?
Yeah, so the main feature of the next hard fork is EIP 4844, which is also known as proto-dig sharding. And the idea of proto-dig sharding is to create some extra space that goes into blocks where like anyone can put data into that space. And this is data that cannot be viewed by transactions, it cannot be executed directly. But the data space is useful in order to allow layer 2s such as rollups to use it. And because rollups are ultimately limited in scalability by the amount of data that they can put on chain in a way that guarantees it will be available. And so 4844 is a way to do this in the short term, but also in the long term, it builds toward a future where we have much more scalability because there is this technology called data availability sampling that will allow users to verify the availability of the data in a block without having to download all of that data. And 4844 is designed in a way that's like very forward compatible with data availability sampling, right? So once you have 4844, you don't need any more hard forks to do data availability sampling. The only thing you would need is to just increase the parameter for how many blocks there are in a blobs there are in a block, and everything else can happen separately with client development.
Cool. So okay. So yeah, seems like we can expect the next hard fork. Okay, so we will move to next section, which is user experience friendly wallet. So I think on the previous section, you guys already talked about account abstraction. So I think this is a very hot topic for a whole ecosystem. So could you give a brief introduction? What is the difference between the EOA and account abstraction?
So EOA stands for externally owned account, meaning it's an account that is owned by a private key. And that private key is external in that it's like outside of Ethereum. It's like you have the private key. And if you have the private key, then you can send any transaction from that account. And so you own all of the assets that that account controls. And if you lose the private key, your ability to control the account is gone. And if someone else has the private key, they can steal all of the assets. So EOA is the most basic type of account. The other type of accounts that exists in Ethereum today is a contract, right? It's an account that is controlled by a piece of code. This is how like basically all Ethereum applications are implemented. But like contracts can also be used to specify the rules for how you can spend from an account, right? So like even today, there exist like smart contracts that are multi-sig wallets, right? So Gnosis Safe, which is now called Safe, is a good implementation of this. Basically, what a multi-sig wallet is it's a wallet that has multiple keys. And so, for example, you could have a wallet that has 6 keys, and you need any 4 of them to send a transaction from that account. And these different keys, they can be owned by either different devices that you control, or different people, or different institutions, or some combination of all 3. And multi-sig wallets are used both by organizations, like the Ethereum Foundation uses a multi-sig wallet to hold most of its funds, and individuals, like I use a multi-sig wallet to hold most of my funds. Like they're just, the main value is just that they're much more secure, right? Because there isn't like one single magic number on your computer where if you lose it, your money is gone, and if it gets stolen, your money is also gone. Now, what account abstraction does is it's a set of standards or like protocol features that allow you to use contract wallets to send transactions directly, right? So what I mean by this is that right now you cannot do this. Right now, when I want to send a transaction from my Gnosis safe, I have to first have a separate externally owned account, and I have to have ETH in that EOA to pay for gas. And then I send operations through that EOA. The EOA pays for the gas, and then it sends a message to the smart contract hitting the signatures, and then the smart contract does what it needs to do. This adds a lot of unnecessary complexity because you have to, like, 1, pay the extra 21,000 gas for the EOA. 2, you need to have your ETH both in this wallet and in this wallet. And like you can try to do fancy things and always refill it, but then what if the gas price goes up a lot and before you thought you had enough money here, but now you don't have enough money here. So there's just a lot of complexity involved. And so with account abstraction, you can just, you would be able to use the smart contract wallet as the origin of your transaction directly, and it would be the smart contract wallet that would pay for the gas. So make things much more convenient in that way, and basically make smart contract wallets a first-class citizen, and sort of pave the path toward them becoming a default that everyone can use to store their funds. Now, account abstraction has a long history, as I've kind of mentioned, right? Like it started actually back in even 2015, and over the last 8 years, we've come closer and closer to understanding like what is an account abstraction standard that simultaneously gives users enough of the things that they actually need, and is practical to implement, and is like actually safe from the perspective of the protocol and the desire to preserve decentralization and all of these goals, right? And that line of research eventually ended up with the current version of ERC-4337, plus the roadmap which aims to first actually turn ERC-4337 back into being a protocol feature over time, and do that first on layer 2s and then do that on layer 1, right? So this is something that's still evolving, but the plan is to evolve it in a way that's fully backwards compatible, and like it's possible to build an ERC-4337 wallet today, and lots of people already are doing that.
Yeah, I think here in Taiwan we have another wallet team called Bottle. They are building a
Yes.
no.
They organized the event in Paris. Like I know it was good to see them leading on that.
Cool. Yeah, just like Vitalik mentioned, that so far, if we want to create a wallet, you need to secure your private key. And for the general user, this is a challenging problem. So, and another part, and another key thing that we can do is just like a red pocket. But for account abstraction, if you want to have a red pocket like Hongbao, then you can create or pre-compute an address. Then we can send the new user some money or token. So this is a really good user experience to onboard a new user. I try to summarize some of the problem of the account abstraction. So yeah, so let's talk about address.
Okay.
Since the very different, very different thing from the EOA and the account abstraction is a country wallet. So since it's a country wallet, the address is not just like the EOA, it's a public key encoding format. It might be changed if we deploy a different code, country code. So how do we, educate user? One day in the future, maybe this is not the same address, just like they used to use.
Right. I mean, I think like if you keep things within one single chain, then it's like it can be done in a way that's relatively simple in the sense that like you can always convert an EOA into an account abstraction wallet that has the exact same functionality, right? So it's possible to do that, but like that actually requires a lot of like features that don't exist yet. Like one is you need an EIP that allows EOAs to convert themselves into smart contract wallets, and then two is you need dApps to like actually follow a lot of standards. Like there's been a collection of EIPs whose goal it is to basically let smart contract wallets do the same kinds of things that people use EOAs to do that go beyond just like signing transactions. So for example, there's EIP 1271, which allows smart contract wallets to sign messages. Right, and recently a lot of dApps rely heavily on off-chain messages, so this is very important. Then there is EIP, I believe it's 6900, which basically allows smart contract wallets that have not yet been put on chain to also make ERC 1271 messages, right? So there's this problem that's called counterfactual addresses, right? Basically, this is something that EOAs already have by default, right? Which is that, like, if you just start using Ethereum for the first time and you download a wallet, then, like, how do I send you money, right? Because, like, you can generate an address and you can send me that address. And, like, we can do this without you having to perform any action on chain to register that address.
Right.
And this is important because registering an address would take transaction fees, and like that's something that you would not be able to do if you did not yet have ETH, but to receive ETH you need to have an address, right? So like if this was not, if this feature did not exist, then like the only way to join Ethereum would be to find a friend who already uses it, which would have limited adoption, right? So with EOAs, this is very simple because the address is just a hash of a public key, and so you can just make addresses whenever you want. With a smart contract wallet, there is this EIP, I think it was EIP 1014 called a Create2, which allows you to make an address which is the hash of a piece of code. And the piece of code basically specifies the conditions for initializing that wallet, right? Which specify the code that the wallet will have and some initial parameters, like what the initial keys are, for example, right? And so then what we're able to do is we're able to say, if let's say you open up a wallet that supports like smart contract accounts for the first time, you can locally generate what your address will be, and then you can send me that address, and then I can send you coins. And then within your first transaction, you'll be able to create the accounts that will exist at that address. And like that, because that address is the hash of a piece of code, the only thing that can exist at that address is the piece of code that you already specified, right? So someone else can't like come in before you and like yoink the money, right? So you'll be able to, within one transaction, create that account and then immediately make your first operation going from that account, right? So same user experience as EOAs, all done kind of under the hood, right? And so that's another thing that needs to be done. Also encryption, I think especially once we start doing more zero knowledge stuff and more decentralized social and more of these things, people will start using accounts as encryption keys. And this is also something that, actually I'm not sure whether or not there is an ERC for this yet, right? But like there is an ERC for stealth addresses, which is a very similar concept to encryption. But I think if there isn't, there needs to be an ERC for encryption, right? But like these standards exist, but dApps do so far not a very good job of supporting them, right? Like there's this really annoying habit where everyone just assumes that you use MetaMask. And like you don't even need to have a smart contract wallet to run into problems. Like often I use my Brave wallet, and which is just a regular EOA wallet as well, and even a Brave wallet has problems, right? So like these are just things that dApps need to fix, and we need to yell at dApps to make sure that they fix them. And one of those areas where adoption could probably only grow over time, but that's fine. So that's one. That's why we have one chain, right?
Yeah.
Some of the challenge comes in once we have this kind of like multi-domain, multi-L2
Yeah.
world.
Right.
Yeah. And there the challenge is that like, you have your different objects that are on different domains, and in some of those cases, you might not be able to have the same address everywhere, right?
Yeah.
I mean, there's two challenges. Like, one is how we do addressing, and then the other is like, one of the advantages of a smart contract wallet is that you can change your keys. But if you change your keys, then like, how do you make sure that information actually propagates to all the layer 2s? And so there is an approach by which like this data can be, like the data about your keys can be stored either on layer 1 or in a specialized layer 2. And then that information can be kind of propagated through to the other layer 2s, using either zero knowledge proofs or sometimes much simpler technology. But this is something that needs to like actually, be implemented, and it's pretty challenging, and there's like different moving parts. And so this is an area where different layers of the ecosystem are going to really need to cooperate to make sure that we do a good job. But I think the big message to wallet makers today is like, if you're making a wallet, you are making a layer 2 wallet. There is no point in making a wallet that is not a layer 2 wallet, right? Mm-hmm. And I think we're seeing projects really moving that way, and building a wallet that's like really tries to think through account abstraction issues and layer 2 scaling issues at the same time. So we're making progress.
Yeah, since we have a different layer 2 solution, and some of the layer 2 solution they are not EVM compatible. So we can imagine that the wallet address should be not the same. Mm-hmm. So maybe I think the ENS would be the kind of solution that we can solve. I forgot the EIP is off-chain resolver.
CCIP.
CCIP. Yeah.
Right. Okay. Well, so what CCIP does is it lets you have ENS names on layer 2, right? Which is also important because if users are going to live on layer 2, then like we want their ENS to also live on layer 2, right? But that's where the ENS lives. There's also like what the ENS represents, right? And like one of the ideas is to have the ENS represent also not just your layer 1 address, but also what your addresses are in the major layer 2s. I do think that there is a problem with this approach, which is that like it doesn't have this property of being friendly to new users, right? Because if you join for the first time, like you do not yet have an ENS name, right? And then there's the other aspect, which is that like it should be possible for someone to change their name without moving everything to a different profile, right? And so like I think there's good arguments for there to be some kind of other abstraction that like is still some kind of cryptographic hash, right? So it's still some kind of address. And so that way you could still generate it offline without needing to publish anything to chain, but can kind of like, sit between ENS and represent not just your addresses on all of these different layer 2s, but also potentially your addresses inside of some of the privacy systems that are being created and stealth addressing systems and all kinds of other things.
Okay, so another part, I think we can talk about signing message. Because with the account abstraction, we user just need to sign the message to represent their intention. So that means the signing message is not necessarily should be in transaction format. It could be any form of the text. Yeah, just like email or like the social messaging. So we can use Telegram and to say, I want to transfer 10 years to Vitalik.
That sounds like a security dystopia, but okay.
Okay.
Like, we're trying to compete with Telegram. But, I mean, okay, if you want to make the Telegram account one of your 5 keys, then that's fine, but not more than one of 5, please.
But I'm not saying using the Telegram key. I'm saying that use the private key secure in the
Oh, I see.
secure element. Now,
Right.
but we still can sign a message on any
Right.
kind of social
Sure,
platform.
yeah. I think no. If you want to use like private keys that are in a secure element on your phone or something, then I think that's great.
Okay. Okay. So from my view, I think that since a construction is a contract wallet, it's really not like to a traditional wallet. We only need to secure the private key. So I'm thinking maybe in the future, I'm not quite sure how many teams can implement the contract securely. Do you think this should be an issue?
Yeah, I mean, my general philosophy is we need to be writing as little code as possible and reusing as much code as possible, which is one reason why I'm happy that like so far there's so many people who are using Gnosis Safe, and even the Safe team has been growing in their willingness to embrace and work around ERC 4337, and so there's going to be more kind of progress on integrating those over time. So yes, like I think it's good. Like basically every wallet creator should by default be using the same code unless they have some specific reason to want something special, right? So like for example, if you want to have something where like one of your 4 backups is some fancy zero knowledge proof that verifies like your Twitter, then like okay, you can do that, right? And that requires custom code. Though even there, the only thing custom is the proving key, right? Like the actual Plonk verifier or whatever, you should just reuse something that exists, right? So trying to, minimizing code reuse is good. People working together on code is good. Auditing and formal verification on code is good. Potentially in the longer term, there might be more features that we have to like actually bring into the protocol, right? So like one example of this is the ERC4337 entry point, which is like the central thing that like actually calls out to all of the different accounts in a bundle and calls to verify them and then calls to execute. Like that itself as the current roadmap is to turn that into a protocol feature. So yeah, I think those are the strategies to try to get more security.
Yeah, and I think that we need to have more social collaboration on the standardization. Yeah.
Yes, we do, and that's something that I've been pushing a lot. It's something, like I think we need more, like dedicated wallet events. Like, there have been research and development retreats to talk about Ethereum protocol stuff, right, for a long time, right? Like, the most recent one was, in Austria back in January, about 100 people, Ethereum Foundation researchers, everyone from the execution clients, everyone from the consensus clients, came together. Like that's not the only one of these, right? And like things like this have been happening for years already, which is good. Like maybe we need something similar for major wallet developers, right? Like maybe like every time there's a major Ethereum event, like there should also be a wallet like standards and co-building workshops happening at the same time, right? So it's like compete on the things where it makes sense to differentiate, but like like basic like security and ecosystem standards should be for everyone. Like I'm hopeful that we can keep improving on this.
That's great. It reminds me that we have we had a sharding workshop here
Yes.
for the diversity client in 2018. Maybe we can run another one.
Yeah.
Okay, so
No, it's a great venue here.
yeah. Okay, so we prepare some of the questions that are proposed by our audience. Okay, so is it hard for you to read?
It's okay. Do I think that much L2 is needed? I mean, yes, because we need scalability. Okay, 1 out of 3 done. This is easy.
Yeah.
Your recent article talked about L3 landscape in the future. Do you think L2s are the end of the day would become a proof aggregator? Also, do you think there is going to be L4, L5? I think no to L4s and L5s, but okay, so here's where like my view on how I think the like higher layer space is going to evolve, right? I think realistically for quite a long time, the L1 will continue to be the home of like major financial stuff, like it'll be the place where the $1 million monkeys happen and like where people trade, one kind of dog coin for another dog coin, and that's fine. I think, but and it'll also be the home that like actually manages the proof systems of all the layer 2s and all of the other stuff. Layer 2s will, I expect, be the place where most financial things for normal people happen, because layer 2s have low enough fees and they have the high security that they demand. Then I expect that there will be a whole range of systems that have different kinds of partial security guarantees. Right, so layer 3s are often like this, right? Like if you look at like even like some of the Validiums that are running inside of Starknet, for example, right? Like what a Validium does is it basically is a system that says there is an operator and the operator can disappear and they can steal your money, but and they can freeze your money, but they cannot steal your money, right? So they can disappear and they can make the system stall, but they cannot make the system do something incorrect. And I actually expect that what's going to happen is, obviously, we've seen Celo, and I expect there's going to be a lot of L1s looking to try to become L2s. But also, I expect there is going to be a lot of centralized systems that will be interested in becoming L3s. Right? Now, why L3s and not L2s? Because L2s still have fees, and a lot of these systems have like very high scalability needs, and so they're going to be too high even for L2s. But like the kinds of systems that I mean are like enterprise stuff, for example, right? Like remember, for a long time we've had this whole Ethereum enterprise thing, and we've been trying to do private chains and consortium chains, but like that effort ended up failing just because consortium chains just can't get enough legitimacy to like really be accepted and can't really benefit from enough developer network effects and all of these things. But I think what can make sense is for all of those applications that the enterprise cool people were saying should run on consortium chains 5 years ago, those should become L3s. Right. Now, why? Imagine you're an enterprise application. Today you're running on a server. You have hundreds of thousands of transactions a second. Your developers are either lazy or they're just too scared to change a system that already runs $20 billion of people's money. And so you might not be willing to turn into being a blockchain thing, but what you will be willing to do is run an extra piece of software that's allowed to call into your existing piece of software, generate Merkle trees, generate Zk snarks proving your state transitions, and publish the roots and the proofs to chain. And then if you do that, you get extra security guarantees because people can see your Merkle proofs, and then individual users will be able to get Merkle branches from the API, and they'll be able to prove like, hey, look in this database, I actually already have a here's a record that some shipment is already coming to me through the postage system, and it'll be here in 24 days, and therefore I should be allowed to take a loan against it. And like it has a Merkle branch, and it proves that it's like over here in the supply chain, and you'll be able to do that. And you'll have the zero-knowledge proofs that are proving that the database actually is being updated correctly, right? So you can have financial stuff depend on it and be confident that it's not going to get hacked, right? And so, but you get benefits, right? And like you get probably about as many benefits as you would get from running on a consortium chain, but you have even more scalability. Because if all you're doing is you keep your server and you're just making proofs, there's no limit to scalability. You keep your privacy because the data is still there and you only need to give the data to the people who need to see it. But at the same time, like you're keeping your existing workflow, right? You're not replacing software, you're adding an extra package that calls into your existing thing and publishes some extra information. So I think for a lot of enterprises, this will be good, and it'll be good for like boring and stodgy enterprises that run human civilization, like supply chain things. But I think it'll also be good for gaming. There's a lot of existing games that I think would be interested in putting proofs on chain, and 0x Park has obviously been doing a lot of experimentation around that with things like Dark Forest, and I expect to see a lot more games that are like this. I
think its change is also good, building on the layer 2 solution.
Yeah, exactly. Right. So I think some of them will be layer 2s, some of them will be layer 3s, right? And I think that's fine, right? But like the point is that like what we basically have now is like we have an upgrade path where things that are not part of Ethereum land today can become part of Ethereum land and benefit from the security, benefit from the shared ecosystem, but at the same time, like, you know, keep the like basically all of their existing workflow, right? And I think that's amazing.
Cool. The third question, do you think that the rollout-centric roadmap and the best rollout are making Ethereum a heterogeneous chain similar to Cosmos or Polkadot? Layer 1 validators have to run various two clients at the same time, which eventually leads to the centralized of validators.
Yeah, I guess there's a few different questions in here, but it's a fascinating one. I think, so just to explain, I think the reason why some of these questions are connected is a based rollup is this idea that you have a rollup where instead of having like some off-chain sequencing mechanism, you have a mechanism where anyone is allowed to submit batches of transactions. And so basically, the layer 1 essentially controls which, you know, the inclusion of transactions in layer 2. And this is nice because if the layer 1 is censorship resistant, this immediately guarantees that the layer 2 is censorship resistant. It like really minimizes the amount of infrastructure that the layer 2 has to build. But there, like, it really pushes a lot of centralization risk on the layer 1, right? Now, there's centralization risk on layer 1 already, right? And this is all why we've been talking for so long about things like proposer-builder separation, right? Where basically you can have specialized actors that can generate the block contents and then block proposers. Instead of having to do all of that themselves, they just accept bids from different people who are creating these block contents. And then they accept whatever the highest bid is, and so they don't have to do any work except for choosing which number is the highest number, right? And like there's challenges around like making sure we have censorship resistance, for example, and so there's been a lot of research recently on what's called inclusion list, which is where the proposer still chooses which transactions have to get included in the next slot, but then, or in either the current slot or the next slot. And then but then it's up to builders to like figure out the order and figure out what other transactions to include, right? So this is, so if you have like a well-running PBS infrastructure, then layer 2s would not be a centralization risk to layer 1 validation because all of that work would be done by builders. Now, do we necessarily fully trust that like PBS will work perfectly, right? No. And so this is actually part of why like I personally am less enthusiastic about base rollups. Like I actually believe in independent sequencing. And one of the reasons why I believe in independent sequencing is because I think there is value in the layer 1 being slower, right? Like layer 1 today has a slow block time, 12 seconds. And I actually think in the future it makes sense for it to become even slower, especially once we do single slot finality. Like I think there's value in layer 1 just having a 32-second slot time where every slot actually finalizes. And then layer 2s, they can do pre-confirmations and they can process their pre-confirmations much more quickly, right? But they could have like blocks every 1 second. And for regular user activity, this might actually be good enough in a lot of cases, right? So that is, yeah, something that I, like if that happens, then one of the side benefits is basically the centralization pressure from sequencing gets taken off of layer 1 and gets moved to layer 2s. And potentially if everything moves to layer 2s, then like layer 1 won't have centralization pressure at all and might not even need PBS, but like I think that's pretty unlikely, right? Which is why I think PBS is good anyway. But like what that would result in at the end is basically, I think, an architecture similar to Cosmos, except you have shared security, right? And like that to me is the goal.
Yeah. Yes. Yeah, we still have a bunch of questions. Sure. This is about society and DID.
Yeah, I mean, I think that's right, using zero-knowledge proofs to verify national ideas. I mean, I think that's good and that's really cool. I mean, I think in this era of AIs becoming more powerful, I think having more ways for people to prove that they're people is going to be very important. And I mean, there's a lot of crypto use cases where it's valuable, like airdrops are one obvious one, right? Like you don't want your airdrops to just be massively farmed to death by VC funds. You want to like actually have lots of different people, you know, like get tokens. And then like I think it's good to have different approaches because I think every one of these approaches has different trade-offs, right? So like for a long time, we've had social graph-based stuff like circles and kind of like proof of humanity, but there's limits to how fast they can grow. And then obviously we have WorldCoin now with biometrics, and that has a lot of advantages, but that has some of its own problems. And like national IDs are, I mean, in some sense they are a social graph, but they're just a centralized social graph where like the countries are the trusted nodes. And like that's far from perfect, but I think as a thing to bootstrap from, like it's totally fine. Like I think in the long-term future, everything will be social graph-based, right? And the value of some of these other tools is to be able to let us bootstrap the social graph more quickly, so that we can be sure that like we actually have some secure cryptographically attested human identities everywhere around the world. So I think that's valuable. Another thing that I think is valuable is if we want users to be moving to these like multi-sig wallets to store most of their funds, you need to actually have like multiple things. Like you need to figure out like who the signers actually are, right? And I think having a government ID be one of the signers is like a totally fine thing to do, right?
Yeah.
Yeah.
Agree.
Yeah.
Yeah.
Do I think blockchain can mitigate social reproduction in some way? Okay, like social reproduction, like what is that? Like how fast memes spread?
I don't know either. Maybe we can skip this question.
Yeah, okay.
Okay.
Is there estimated time for the next upgrade? I'm not the time guy. Ask Tim. His name is 3/4 of time. And a more exact estimation of how much the roll-up cost will be reduced. Estimating cost is hard, right? I think because the number is that I believe the plan is to have 384 kilobytes per block per slot of data space, which is like 4 times as much as the average amount of data in an existing Ethereum block, and that would go just to rollups. So how much that would reduce rollup cost is hard to tell, because on the one hand, it's like 5x supply. And I remember doing a historical analysis that suggests that the demand elasticity is about 1, and so if you 5x the supply, you're cutting the cost by 5x. But then, like, it's possible that there's just a lot of extra demands to use rollups, and lots of people will switch to it. And like, instead of reducing fees, we'll have similar fees, but like things that are less decentralized today become more decentralized tomorrow, right? And so I think even after 4844, we are going to need to start expanding scalability pretty soon, even after that. How about the Ethereum Cancun now? How will this update change the layer 2 ecosystem? It will reduce fees, and it will allow things that are centralized today to become decentralized.
Yeah. Okay. Next. This is about fund allocation. I think it is a diversity problem.
It's good. Okay. The Retro PGF, organized by Optimism, is open for everyone to participate, but the current badge holder is predominantly composed of native English speakers. While many Chinese readers are capable of comprehending English content, there are considerably fewer English readers who engage with Chinese content. How do you perceive the resource allocation disparity that Chinese media faces on the Retro PGF? Yeah, I mean, I think it's a good question, and I think it's an important one, especially now. And one of the reasons why it's important now is that I think some of these newer technology areas are like actually creating big opportunities for people to participate when like those countries were not able to really participate in Ethereum research and development much before, right? So ZK EVMs are one, and 4844 is another. Like there's just huge Chinese communities, for example, in both of those areas, right? And I think sometimes like you need these like new technology kind of like trends to start just like as a reset, so that new people can come in and not feel like they're 10 years behind people who have already been doing things for a decade. But then like with that opportunity, obviously, like we need to actually properly take advantage of it, right? And making sure that like Retro PGF, for example, properly like knows about and recognizes those projects. I mean, I definitely agree. It's super important. I mean, I actually did remember I brought up that issue with the optimism team. I think back when they were initially designing it, I think it's the challenge is definitely that like the optimism team in particular has been historically like pretty U.S. centric, and for them to expand more will probably take a much more intentional effort on their part. And I hope that they do that, and I also hope at the same time that they're not the only ones, and we see other retro PGF projects start to happen. Yeah.
Cool. Yeah. Oh, this is I think this is the last question is about the value of decentralization. Yeah.
We've been emphasizing the importance of decentralization. The consensus protocol has been working around this. After POS, we see validators are split into different roles when considering infrastructure, interest, structure, and behavioral complexity. It covers several aspects to achieve decentralization, including to avoid the authority concentration, fund concentration, intensive computing resources, and the specialization brought by the solver architecture from the recent hot topic of intent-centric. Somehow I feel like the centralization seems to be inevitable, and I would like to know what Vitalik think about this. Yeah, I mean, it's a good question. I mean, I think like some of the centralization is definitely inevitable, but I think some of the centralization is also just like a result of like protocol decisions that get made and choices that get made, right? So like one example of this, maybe I feel like everyone talks about staking now, but like just to talk about a different field, like wallets and like light client support, right? Like today, most people who connect to Ethereum basically connect to Ethereum by trusting Infura, right? And or potentially trusting some other third-party node provider. And like this is potentially dangerous, right? Because if the node provider gets hacked, they can feed users wrong information, and they can probably steal a lot of money from users. Like if you just control Infura, you can't just immediately steal all of a person's assets, but you can like show incorrect prices and potentially grab a lot of people's money when they use swaps, for example, right? So there are technologies that can fix this, right? And the challenge, of course, is that running your own Ethereum node right now is just something that requires a lot of computing resources, and it's complicated. And the Geth team has actually been doing a really brilliant work in trying to reduce the cost of running a node as much as they can. Like right now, I remember I saw Peter Szilagyi on X posting some like messages like about his some of the work that he's been doing to improve the database design and how that improves sync time and reduces the database size, right? So you can do a lot, but like there's still a limit to how much you can do. And I think the future there, I mean, in the short, like if we want people to, especially like on phones, for example, which like cannot even have 200 gigabytes, right? To still have security, like the first step is light client protocols. So Ethereum proof of stake does have a light client protocol, and there's a system called Helios by A16Z that basically does a ZK snark over the light client protocol, and that lets it like basically be a kind of verifying proxy for Ethereum. So if you use it, like if you run Helios and you point your RPC to it, then you get some like a light client level guarantee. But then also like having that on phones is good, and then in the longer term future, like we need stateless clients, and then after that we finally need like layer 1 ZK VMs. And then the dream is that it should be possible for people to run a full node even on a phone. It's actually like less hard than it seems. The reason is that like phones are not good at computation, but they're totally fine for bandwidth. And so what you can do is if you have all of this zero knowledge proof infrastructure, we can imagine a world where what a light client does is it downloads a block, downloads maybe 100 kilobytes, maybe a few megabytes, whatever amount of data, then computes a hash over all of that data, verifies a snark, and that's it, verified the block, right? So that's the kind of future that I want to like see Ethereum full nodes become, but like that's technology thing that needs to be built. And while the technology thing is not built, then like everyone goes and trusts in Fura, right? Or another example is like while account abstraction and low fees are not practically available for users, then like for a lot of people, especially less technical people and people in like, for example, third world countries that are, like have a lot of problems with things like currency devaluation and they have a real need for crypto, they like a lot of people there just like don't have any practical option other than using Binance accounts today, right? And like it's it's good that they have options and that they're providing like that option that's bringing them value right now. But like the ideal is to have like decentralized systems actually be available even to those people, and that's like something that needs to actually be built and actually get done.
Yeah, I think it takes time to make a progress, but we can see a lot of progress have already been done since 5 years, maybe 5 years ago. In 2018, I think Vitalik's talk in Taipei says we want to solve the scaling problem, pricing problem, Litecoin problem, blah, blah, blah. Yeah, but we can see EF have
Like
already.
clients exist now.
Yeah.
I think like a lot of problems do get solved, right? I think what happens is that often our standards go up, right? Like by the standards of like 2015, for example, like we now have solved the like client problem. It just needs to be adopted, right? But now we're more ambitious and we want to like actually have full zkVM verification, right? And then we talked a lot about proof of stake, and now proof of stake is actually done, but now we want to do single swap finality and PBS, right? So things that like really are getting done, and huge amounts of progress are being made. But like at the same time, there's definitely still more work left to go.
Yeah, and one of the things that EF Research, EF Foundation doing pretty right, I think is they open source all of the code and open all of the documents, open source all of the documents. And also EF Research team has a regular AMA on Reddit. So this is a pretty transparent and very benefit for all of the users who want to join into the Ethereum ecosystem. Yeah, so I'm pretty encouraged if you guys have chance, please to read this document. Okay, so the last question, do you have any words you want to encourage our Taiwan community?
I mean, I feel like I've said a lot of things already, but I mean, in general, I think this is a great time to really start contributing, because there's a lot of different things that you can start contributing on, and there's a lot of these very new fields that are emerging where it's possible for new people to get in and not feel like you're 5 or 10 years behind people who have been doing this for a long time already, right? Like the whole layer 2 space, the application space. I mean, in ZK Synarchs, I think the thing that has only become possible over the last year is like it's become possible for people who do not understand the details of zero knowledge proofs themselves to build ZK Snark based applications, right? And that's new, and that's something that you can do now. So yeah, I think there's a lot of opportunities in technology, and I think in addition to the technology, there's a lot of other kinds of work that needs to be done, right? So I think on the community aspect, like one thing I want to repeat is just this desire to that like as a community we can like actually start to really use some of these things more, right? Like if we have meetups, like actually use either Popes or ZooPass or like fancy some of these blockchain or zero knowledge proof based things as tickets for the events. Like try to see if we can pay with a cryptocurrency for things. Like see if we can actually use decentralized social media. Like Lens exists, Farcaster exists, Status.am exists. It's existed for 5 years, but it's quietly getting better. And so like I'm increasingly spending more of my time on some of these things. Skiff also exists. Like sign in with Ethereum, decentralized, well, semi-decentralized email, like with encryption. So yeah, that's like a lot of these things are getting built, and like there's value in as a community kind of supporting each other, and also just like helping people who are doing work to like find each other and like actually like make sure that we're all cooperating and working towards a goal, and together with each other and together with parts of the wider world. So I hope that we can all play our part in doing that. Yeah.
Okay.
Thank
you.
Yeah.
Thank you.
Also, I've been instructed to deliver a message to someone named Anderson. Is there someone like there? Can you wave or something? Stand up, wave, anyone?
Stand up.
Happy birthday to you. Happy birthday to you. Happy birthday, dear Anderson. Happy birthday to you.
Cool. Yeah, I think it must be a unforgettable memory. Okay, so thanks for Vitalik for answering lots of questions, and yeah, thank you.
Thank you.